Hi guys, so here we have circle theorems, a question on circle theorems. The question saying A, B, C, D and E lie on the circle, on a circle, right? You can see them A, B, C, D there, and E. Find the values of X, Y, and Z. Don't try to get the values right away, you know. So normally what you do, you look at the diagram and then you have to think of all the circle theorems that you probably know, and maybe any other angle facts that you may recall, right? And don't assume things that you're not told. Sometimes, people assume that with parallel lines here, this and that, they form 90 degrees, but if you're not told, please don't assume. What you're simply using here are the circle theorems, right? So we'll start with those that are basic. Angles subtended by the same chord, and they appear on the circumference, right? So if you look at AB, okay, maybe before we start like attempting to answer the question, what I'll urge you to do is try to fill in all the missing angles on the diagram before you start answering or picking out what is X, what was Y, and what is Z. Okay, so let's look at AB. You can see AB is actually a chord, right? This is what I'm looking at. This is AB. It's a chord, right? And then if you check very well, there is this angle that is formed at the circumference up there. If I come back this way, right, this angle formed here. Right, the very same chord is carrying another angle at the circumference. If you look at this direction coming from here all the way up to that point and coming back here. Right, so what does the theorem say? The theorem says angles subtended by the same chord at the circumference. And of course, those angles will be in the same segment because AB is creating two segments. Okay, there is this minor segment down here and everything else up there, that's the major segment. So angles subtended by the same chord at the circumference and they appear in the same segment, those angles are equal. That's what the theorem says. So we automatically have 52 degrees here. This angle is 52 degrees there because of that fact, right? What else can we see here? If you check closely again, let me clear these lines. I hope you've seen this one. Right, so I'm just going to erase this. I have 52 there, so we already know this is 52 degrees. Again, there is a chord here, this chord AE. You can see AE is carrying this angle, right? If you go all the way to the circumference there, right, there's this angle here, it's 26 degrees. Then again, from the same chord, we have this angle at the circumference. This is also 26 degrees. Okay, so I'm going to clear that. Those lines, they must go, right? Those lines must go. Super. So that's 26 degrees here. Okay, what else do we have? I'm sure you can see, if you look very closely, there's a four-sided shape here. We call those cyclic quadrilaterals. If you look at A, B, C, E, right, this is a cyclic quadrilateral. If you look closely, right, this is a four-sided shape. And we know from a cyclic quadrilateral, opposite angles, they always add up to 180 degrees. So what's the sum of those two? That is 26 plus 52 there. We get 78 degrees. So if this whole angle is 78 degrees, it means this side, this whole angle here, is actually 180 degrees minus 78. Give 1 there, give 8 here, though we have 102 degrees. So this whole angle is 102 degrees. You could have found this by just using triangle ABE as well. I'm sure you can see that, huh? Right. What else do we have? Okay, you can see there's 125 here, right? That's 125. It means we also have 125 degrees there. right? Vertically opposite angles, they always sum up to, yes, that value. What else do we have? What else do we have? What else can we find? We can probably find this angle here, right? This is now a triangle. If you look very closely, this is a triangle, right? That's a triangle. So 125 plus 26, right? 11 there. We have 151 degrees. Then 180 minus 151 degrees, give 1 there. This becomes 6. 10 minus that, 9. 8 minus 29 degrees. So this is 29 degrees. Now once we have found 29 degrees here, we can see BC is actually a chord that is carrying an angle at the circumference. If you see this chord, right, carries this angle here at the circumference, and also carries that one there at the circumference. So that angle as well is 29 degrees. Right. What can we find now? I think we can find this one. That's if it's possible. Right, let's look around, let's see what we can get. Super. So if this is 29 here, if this is 29, we can actually calculate this one. Right, so we are saying 102 minus 29. Right, 102 minus 29. Right, I hate these small calculations. I don't like them because 102 minus 29, they have 73 degrees. This is 73, and automatically this becomes 73 degrees. You can see there is a, hey, my diagram looks very clumsy. Right, but then anyway, we need those lines just for reference sake. So I'll use a different color. If you check here, you see this one. This carries this angle at the circumference, this one, and also subtends this angle there at the circumference. So if this is 73 degrees, that one is also 73. And then if you look, there's another cyclic quadrilateral that can help us to find the value of Z there. If you look at EDCB, that's a cyclic quad, okay? Right, let me check for another color, a unique one, so that at least, right, how things are not clumsy, too clumsy. Right, if I'm looking at this, right, I'm sure you can see that all the way here, going this way and that way. Right, you can see B and D, they are opposite in a cyclic quad, so we can actually say 180 degrees minus 73, right, to get Z. 180 minus 73, this is 107 degrees, so that is 107 degrees. I think we found all our angles here. So from here now we can come down and say, okay, what is the value of X? X is 29 degrees. What's the value of Y? You look around 52 degrees. All right, and then what's the value of Z? Is just 107. So the task, what you need to do